Welcome to Math Solutions by Pani. We are in exercise 5A. We already finished till the question number 14. Now we will start question number 15. This is related to limits and continuity. Okay, dear students. Show that the function defined by g of x equal to x minus step x is discontinuous at at all integral points. So we will check at one point where it is continuous or not. We will find out. So what I am going to do is, given f of x equal to g of x minus step x let x is equal to any one. 1 belongs to or you have to take it. At x is equal to 1, we are going to verify the continuity. 1 belongs to R, and checking the continuity, at x is equal to 1, the function value g of 1 is equal to 1 minus step 1, that is equal to 1 minus step 1 value is 1, that is equal to 0. Keep that equation number 1, dear students. Later, limit x tends to 1 plus g of x. X tends to 1 plus meaning is x is greater than 1. X tends to 1 plus meaning is x is greater than 1. So you have to consider 1 point something, 1.25, let us consider like this. So what we have to consider? So limit x tends to 1 plus g of x is x minus step x, no? So step x value is what? If you're taking x is greater than 1, less than 2, step of 1.25, it will be 1 itself, no? So x is equal to 1, substitute, minus step x value is 1, equal to 0, equation number 2. Limit x tends to 1 minus g of x. Limit x tends to 1 minus x minus step x. X tends to 1 minus in the sense x is less than 1. That means x is greater than 0, x is less than 1. So let us consider the value of x is equal to 1 by 2. Am I right? That means 0.5. So step x is equal to step 0.5 is equal to 0. So which is equal to x is equal to 1, substitute, minus step x value is 0, which is equal to 1. From equation 1 and 2 and 3, from 1, 2 and 3, we conclude that g of 1 is equal to limit x tends to 1 plus g of x, but not equal to limit x tends to 1 minus g of x. So any one of them is not equal, therefore g of x is not continuous. That is, at x is equal to 1 belongs to R, like x belongs to R, x is equal to some constant belongs to R, g of x is discontinuous at all integral points, hence proved. Otherwise, hence the result. Okay, dear students, we'll move to question number 16. In that question number 16, they're asking to find whether the function is continuous at x is equal to pi or not. So like previous problems, first given function f of x is equal to x square minus sin x plus 5. Later, at x is equal to pi, function value f of pi equal to, so pi square minus sin pi plus 5. So pi square, sin pi value 0 plus 5. Equation number 1. F of pi, how it comes? By taking the limit x tends to pi, f of x, limit x tends to pi, x square minus sin x plus 5. So x is equal to pi, substitute pi square minus sin pi plus 5. So which is equal to pi square minus 0 plus 5 equal to pi square plus 5, equation number 2. From 1 and 2, f of pi is equal to limit x tends to pi f of x. Both are equal to what? A pi square plus 5. Therefore, whenever both are equal, f of x is continuous at x is equal to pi. Okay, dear students, I hope you understand. Next, the question is find all points of discontinuity of f where f of x is this one. So first given function f of x is equal to sin x by x if x is less than 0, x plus 1 if x is greater than or equal to 0. First, at x is equal to 0, f of 0 value equal to, so in place of x substitute 0, 0 plus 1 which is equal to 1, keep it as equation number 1. Limit x tends to 0 plus f of x. X tends to 0 plus means x is greater than 0. Again you have to consider the same function. Limit x tends to 0 plus x plus 1, x is equal to 0, substitute 0 plus 1 which is equal to 1, equation number 2. Limit x tends to 0 minus f of x. Limit x tends to 0 minus. X tends to 0 minus means which function you have to consider? This function. So sin x by x. We know that limit x tends to 0, sin x by x is what? 1. From 1, 2 and 3, we conclude that f of 0 is equal to limit x tends to 0 plus f of x is also equal to limit x tends to 0 minus f of x. All are equal to 1. Therefore, f of x is continuous at x is equal to 0. F of x is continuous at x is equal to 0. That means, that is, there are no points of discontinuity. No points of discontinuity. Okay, dear students, I hope you understand. We'll move on to the next question. We will write it. Next question number 18, dear students. Determine if f of x defined by f of x is equal to x square into sine 1 by x. If x is not equal to 0, 0 if x is equal to 0 is continuous function, question mark, continuous. See, in what way we will prove this function is continuous? See, dear students, first find out the value of function at x is equal to 0. F of x is already there. In exam, again you have to write it, dear students, after giving the question. F of x is equal to, now also I am writing x square into sine of 1 by x. If x is not equal to 0, 0 if x is equal to 0. At x is equal to 0, function value f of 0 is equal to 0. Keep that equation number 1, dear students. Next, later what we have to do, now for this is oscillating function, dear students. Oscillating function like sine 1 by x means we have sine 1 by x lies between minus 1 and but the function is x square times no, so multiplying x square minus x square is less than or equal to x square sine 1 by x is less than or equal to x square. By taking the limit for every term in this inequality, taking the limit to the inequality for the above, simply limit x tends to 0 minus x square is less than or equal to limit x tends to 0 x square into sine of 1 by x is less than or equal to limit x tends to 0 x square. So x is equal to 0 substitute means 0 will come, less than or equal to. This we are going to calculate less x tends to 0, x square of sine of 1 by x is less than or equal to 0. So whenever the limit of a function lies between 0 and 0, then the limit value goes to be 0, dear students. Therefore, limit x tends to 0, x square sine 1 by x equal to 0. Okay, I hope you understand. So this is equation number 2. From 1 and 2 we conclude that f of x is continuous. Sir, how can you say that it is continuous? Since f of 0 is equal to limit x tends to 0 f of x. In place of f of x, that value is there known. Limit x tends to 0, x square sine 1 by x. Okay, dear students, I hope you understand. Till there, we completed. Next, we will move to question number 19. This is the way we can do, dear students, step by step. Maximum, I am giving spoon feeding answers. If really helpful for you, please like and share. And if you like this video, it reaches to more students. That is my sincere request to all people. Examine the continuity. Examine the continuity. Examine the continuity of f. F means f of x, where f is defined by where f is defined by f of x is equal to sin x minus cos x if x is not equal to 0, minus 1 if x is equal to 0. So we need to verify whether it is continuous or not. So f of x is equal to, dear students, sin x minus cos x if x is not equal to 0, minus 1 if x is equal to 0. At x is equal to 0, f of 0 is equal to minus 1. Keep it as equation number 1. F of 0, how it comes? By taking the limit. Limit x tends to 0, f of x is equal to limit x tends to 0, f of x means sin x minus cos x. X is equal to 0 means sin 0 minus cos 0. Sin 0 is 0 minus 1. So minus 1. Equation number 2. From 1 and 2 we conclude that f of 0 is equal to limit x tends to 0 f of x that is equal to minus 1. Therefore, f of x is continuous whenever it happens. F of x is continuous at x is equal to 0. Okay, students. I hope you understand. We'll move to the next question, number 20. Question number 20. Find the values of, for all the question, k is common distance from question number 20 to 21. Find the values of k. Find the values of k so that the function f is continuous at the indicated point of the following So now question number 20. So just I'm writing the function f of x is equal to k cos x by pi minus 2x if x is not equal to pi by 2. 3 if x is equal to pi by 2. So at x is equal to pi by 2 is the question, dear students. So it's a very good question conceptually. Please like and share. Those who are watching, please like. If you like this video, it reaches to more students. That is the reason I'm requesting you. So first what we have to do is at x is equal to pi by 2, function value is 3, no? At x is equal to pi by 2, f of pi by 2 is equal to 3, equation number 1. F of pi by 2, how it comes? By considering now limit extends to pi by 2, f of x. Limit extends to pi by 2. What is f of x, dear students? K cos x by pi minus 2x. So here only is a good twist. Limit extends to, Astita Bigna channel, thank you for joining the session. Limit extends to pi by 2 means x minus pi by 2 tends to 0. That pi by 2 will bring in this side. So k will bring outside of this constant. Cos x can be written as sine of pi by 2 minus x, no? Divided by, even here also 2 I am taking common, then pi by 2 minus x I am writing, dear students. I hope you understand. So 2 bring outside, so k by 2 is constant. Ashritakil, thank you. Nice explanation. Thank you. Limit extends to pi by 2 means x minus pi by 2 tends to 0. Limit x minus pi by 2 or pi by 2 minus x. Sine of pi by 2 minus x by pi by 2 minus x. We have the result limit x tends to 0, sin x by x is equal to 1 is a good result. So it is in the form of limit x tends to 0, sin x by x. So k by 2 into 1, which is equal to k by 2. Equation number 2. From 1 and 2, from 1 and 2, and 2, f is continuous, f is continuous at x is equal to pi by 2, then f of pi by 2 is equal to limit x tends to pi by 2 f of x. F of pi by 2 value from 1 it is 3. F of limit x tends to pi by 2 f of x value we got it as k by 2. So that implies that k is equal to 6. Therefore, when k is equal to 6, the given function is continuous. Okay, dear students, we'll move to question number 21. Just I already wrote that. Yes, question number 21. Write the function. F of x is equal to kx square if x is less than or equal to 2, 3 if x is greater than 2, at x is equal to 2. See how we are going to explain. So like a previous procedure, what we have following. First given function, this we have to write it. At x is equal to 2, the function value x is equal to 2, substitute f of 2, x is equal to, here we have to substitute, dear students, greater than, less than or equal to is there, no? So at x is equal to 2, k into 2 square. Since when x is 2, x is equal to 2, this function you have to consider. Since f of x is equal to kx square, when x is equal to 2, dear students. So it will be 4k. Keep that equation number 1. Next, limit x tends to 2, f of x. Here the thing is, right and left hand limit we can calculate. Limit x tends to 2 plus f of x. Limit x tends to 2 plus meaning is x is greater than 2. X is greater than 2, the function value is 3. So limit of any constant is constant. Equation number 2. Next, left hand limit. Limit x tends to 2 minus f of x is equal to limit x tends to 2 minus x tends to 2 minus x is less than 2. This function you have to consider kx square. So k into x value is 2 square. So which is equal to 4k. Equation number 3. Since f of x is continuous, f of x is continuous at x is equal to 2, then f of 2 is equal to LHL is equal to RHL. So f of 2 value is 4k, LHL is 3, that is equal to RHL value is 4k. So by equating any one of them, k is equal to 3 by 4. So the value of k is 3 by 4. I hope you understand it, students. We'll move on to the next question. In 21, 20, 22, 23. These questions are related to KDA, students. So we'll move to the next one. See, question number 22. So question number 22 is f of x is equal to kx plus 1 if x is less than or equal to pi, cos x if x is greater than pi, at x is equal to pi. This is the question. At x is equal to pi, the function value. Here, whenever plus greater than less than is given, left hand limit, right hand limit, all we can calculate. At x is equal to pi, the function value f of pi is equal to, or equal to is there, no. So here k into pi plus 1, equation number 1. Next, left hand limit LHL at x is equal to pi. Limit extends to pi minus f of x. Extends to pi minus means x is less than pi. So limit extends to pi minus less than pi means x is less than pi, this function kx plus 1. X is equal to pi, substitute k pi plus 1. Next, RHL at x is equal to pi. Limit extends to pi plus f of x. Extends to pi plus means x is greater than pi. X is greater than pi, function value is what? Limit extends to pi plus cos x. So x is equal to pi, substitute cos pi, that is equal to minus 1, equation number 3. Therefore, f of x is continuous. F of x is continuous at x is equal to pi. Then we have f of pi, that means from 1 and 2 and 3. LHL, that is equal to RHL. F of pi value is k pi plus 1. LHL value is also k pi plus 1. RHL value is minus 1. So equating these two, dear students. So k pi is equal to minus 2. 1 also bring this side. So k is equal to minus 2 by pi. So for the value of k equal to minus 2 by pi, the function is continuous. Okay. We will check out, dear students. K is equal to 6, k is equal to 3 by 4 also we got. Next, k is equal to minus 2 by pi. K is equal to next 9 by 5. We need to get it. Next, question number 23. So what is the function we have? F of x equal to kx plus 1 if x is less than or equal to 5, three x minus 5 if x is greater than 5 at x is equal to 5. See, dear students, how we will follow this. First, at x is equal to 5 here. This pen is over. At x is equal to 5, the function value f of 5 is equal to k into 5 plus 1, which is equal to 5k plus 1. Keep that equation number 1. Next, LHL at x is equal to 5. Left hand limit. Okay, dear students. Limit x tends to 5 minus f of x. X tends to 5 minus means x is less than 5. Again you have to get the same function. Limit x tends to 5 minus kx plus 1. X is equal to 5, substitute 5k plus 1, equation number 2. RHL at x is equal to 5. Limit x tends to 5 plus f of x. Limit x tends to 5 plus, x tends to 5 plus means x is greater than 5. We have to consider this function. 3x minus 5. X is equal to 5, substitute 3 into 5 minus 5. 15 minus 5, 10. Equation number 3. So therefore, f of x is continuous. F of x is continuous. At x is equal to 5, then we have from 1 and 2 and 3, f of 5 is equal to limit extends, that means LHL is equal to RHL. F of 5 value how much, dear students? 5k plus 1. Even LHL also 5k plus 1 is equal to RHL value. RHL value is what? 10. So by anything, either equating these two or equating these two, I am going to equate these two. So 5k plus 1 is equal to 10. That implies 5k is equal to 10 minus 1. So 5k is equal to 9. K is equal to 9 by 5. So hence the result, dear students. We will move to question number 24. In the question number 24, we have little find the values of A and B such that the function defined by f of x is equal to 5 if x is less than or equal to 2, ax plus b if 2 is less than x is less than 10, 21 if x is greater than or equal to 10. Is continuous function function. It's a good question, dear students. So conceptually it's a good question. So we need to decide the question. So in what way we can? First function, anyway we can write it. F of x is continuous. F of x is continuous at x is equal to 2. First I am writing, dear students. f of x is continuous at x is equal to 2. That means what? That is f of 2 is equal to limit x tends to 2 plus f of x, that is also equal to limit x tends to 2 minus f of x. F of 2 means what? X is equal to less than or equal to 2. So f of 2 value is 5. Limit x tends to 2 plus, x tends to 2 plus means x is greater than 2. 2 is less than x is nothing but x is greater than 2. So in place of f of x, you have to replace with ax plus b is equal to limit x tends to 2 minus, x tends to 2 minus means x is less than 2. X is less than 2 means again this value is equal to 5. So now substitute. So 5 is equal to limit of constant 5 equal to x is equal to 2, substitute a into 2 plus b is equal to 5. So either these two or these two you can equate. You will get one equation, dear students. 2a plus b is equal to 5. Keep it as equation number 1. Similarly, this is the first point. The second point is f of x is continuous at x is equal to 10. That means f of 10 is equal to limit x tends to 10 plus f of x, that is also equal to limit x tends to 10 minus f of x. F of 10 means at x is equal to x is equal to 10. If you substitute this values will become 21. From this limit x tends to 10 plus x is greater than 10. X is greater than 10 means again this f of x value is 21. Limit x tends to 10 minus x is less than 10. The function value is ax plus b, dear students. So 21, even limit of constant 21 equal to a into 10 plus b. So equating these two, you will get 10 into a 10a plus b is equal to 21, equation number 2. Solving 1 and 2, you will get solving 1 and 2. So 10a plus b is equal to 21. 2a plus b is equal to 5. So now I am subtracting, sign changes. These two will be cancelled. 10a minus 2a is 8a is equal to 21 minus 5 is 16. So a is equal to 2. So a is equal to 2, substitute in equation number 1. So 2 into 2 plus b is equal to 5. 4 plus b is equal to 5. So b is equal to 5 minus 4 equal to 1. Therefore, b is equal to 1. They are asking to find the values of a and b. Therefore, the values of a and b. Therefore, the values of a and b are respectively 2 and 1 or 2 and 1. Okay, dear students, I hope you understand. We'll move on to the other question. #24. Dear students, from question number 24, 25 to the rest of the questions I will finish in tomorrow's class. Why? Because it's too late. I need to prepare some other concept. Thank you for joining this session. Thank you all of you. Those who are watching, please like. If you like this video, it reaches to more students. Thank you for your support. Tomorrow I will finish this exercise and we will enter into the differentiation itself. Thank you.